think we'll get started, and other folks can just filter in as they come. All right, everyone. Welcome to another How to Hex. The theme of this month's How to Hex is AI-enabled data apps, which is a pretty cool topic. I'm really excited to show off this demo and teach you all about this pattern. It's not necessarily a Hex-specific pattern, so even if you're a super new Hex user, you'll be able to figure out ways to apply this both in your Hex projects and other projects, hopefully. And yeah, I've been using this in a couple of my apps, and I found it to be a really neat power up. So I'm excited to teach you. The way that these sessions work, it's pretty informal. We're here for about 30 minutes. I am going to give a demo for about 15 of those minutes, and then we'll save the back half, 15, maybe 10, depending on how long the demo runs, for questions from you all about the demo, about anything Hex related. I'm happy to dive into the product. We can get hands-on, and I'll show you anything you're interested in. So please ask questions in the chat throughout. I might not get to them until the end, but please tee them up there because we'll go through Q&A more or less in the order of questions. So please call things out. Okay, without further ado, those are all the slides I've got because we're going to mostly be doing a live demo. So let's jump into Hex. So I have a project here that we are going to sort of rebuild part of together today. So this is a San Francisco real estate portfolio radar. Basically, I'm pretending, and here I'll make this way bigger, way bigger. I'm essentially pretending that we are a real estate company. Let me rerun this. That has a bunch of properties in San Francisco, and we want to know what's happening in the general vicinity of these properties. And that has kind of a broad connotation, new businesses opening, police calls, code violations, etc. And so I've built this app based on San Francisco public data that lets me look at all of my properties here. So I've got properties where these little red dots are, and then around them, various things that are happening, from crime reports like a theft incident to a new business opening right around the corner from this Union Street property, to evictions, police calls, etc. So I've sort of built myself this little radar map that lets me scrub through the months, and this is historical data, so otherwise I would have done it real time, and get a sense of what's going on around specifically my properties, with regards to all of these things, which is helpful, maybe for a big landlord to know about. And we can configure the radius around our properties using this slider. And so maybe we'll make this super big radius and we'll get a ton of data back. It might actually crash if it gets a lot of data. No. But it's probably better to keep it to a relatively small radius. And I'll show you how we're doing this on the back end after. But the real thing that I want to demo today is that this would be a fine app by itself. This would be a useful report, but I've done something pretty cool, and I've baked in an AI generated summary of the data to this project. So if we change our settings to look at, what are we looking at right now? March, and a pretty small filter radius around here. And then we look down here, we have this AI generated summary of the data, and it says, police calls have increased by 15%. There's a noticeable rise in theft. Evictions are decreasing, which is interesting for us. Business closures have been rising. So it's kind of these mixed messages, and it gives me a sense of the key changes here. An increase in police calls, decrease in evictions, some specific examples of the kind of evictions that have been being reduced, and then a couple noticeable or notable incidents, as well as an overall comparison to city trends. And I can actually see the data that it's building this summary off of down here below. So if I want to drill in deeper than the summary, I can see the data. And then if we go back, and change our filter settings to look at January, it will take a second for the AI to do its thing, but we'll see that this summary is refreshing. And after a couple of seconds, we'll get a brand new summary of all of the data that's powering this app. And so we'll be able to sort of see at a glance the AI generated summary of all this data. I've actually found this really helpful, beyond just a gimmick. I like to intersperse it into apps that also have their own data displays. Like here we have, the map, and I can drill in and look at the individual data points myself. And down here we have aggregated charts showing the overall trends that I can ground truth it and make sure that the AI is, being uh, correct. Um, but I've found having these summaries really, really helpful. And I'm going to show you how I built this. So let's pop over to the notebook view of this Hex project. And this is sort of a complicated project because I'm doing a lot of like geospatial analysis, pulling in a lot of data. I'm not going to go over all of those details, but I'll give you a rough sense of the layout of this project. If you're not familiar with Hex yet, it's a notebook-based tool for working with data. It's pretty different than just a traditional notebook, but you see here that we have, typical notebook things like a Python cell, and then we're looking at this data in a hex table cell. And so hex takes the concept of notebook cells, extends it to way more than just Python cells, adding in, SQL, charts, input sliders, all of those things you just saw. So over the course of this notebook, I'm loading in data from my properties from a CSV file, taking a look at that here. So these are the properties I own. And then we're pulling in a bunch of public data from San Francisco public data from a Snowflake warehouse that I've loaded it into. And we're parameterizing this query with this hex input parameter that I've configured here. So when I change this slider, this query automatically re-executes with the new input that I've chosen. That's sort of how that app is powered. The rest of this notebook is just doing a bunch of, geospatial radius calculations, pulling in all of that data, prepping all of these data sets. It's a whole lot of like data cleaning, you guys know the drill. And in this copy of the notebook, I actually haven't built out the AI component yet. So we're going to do it together right now. So here I've done a really quick little sampling of the recent activity, just because I want to pass the AI model a smaller subset to save money and time. You could, configure this yourself. We'll add a new Python cell here, and we have access to all of these data frames that are being pulled from our SQL warehouse up above. We can use them in Python. So I'm going to import a few things. And we're going to be using the Anthropic Claude API today. And I'll initialize the Anthropic API, say Anthropic. We need to give it an API key, which I already have loaded in as a secret. One cool thing about Hex is that we have support for secrets. So this is an environment variable, but if I print it, you actually can't see it. It will still pass correctly into this function, but you can't accidentally leak it to a viewer of your app or, attendee of your webinar. So sorry, you can't use my key. And then I'm going to paste in this big prompt that I've already written. It would take a while to write, so I'm just going to paste it in. But this is a classic LLM prompt. I'm saying analyze the following data for these neighborhoods. And then I'm passing in these little placeholders for the data sets that I've configured here as stringified data frames. So I'm saying here's police calls, here's the current period, here's the previous period, so it can do those trend calculations. I'm being very specific about what I want, provide a detailed quantitative summary. Your analysis should be highly specific. And you'll be able to look through this later, and you can read Anthropic's prompting documentation for advice on this stuff. I've found the best way to do this is to just iterate and explore and experiment and figure out the specific things you want it to do, and then just implement them and test. And I'm telling it to format the response as JSON. And this is really important because I want to consume this and sort of structure my report after. There's various ways to do this. Some are like more strictly guardrailed and typed than this. But this actually works pretty well these days to literally just say, hey, here's the shape of the object I want you to give me back. So we'll say this. And then cheat sheet here because I don't remember. Let's write a function that will analyze all of this. I think I have this written out here somewhere. Since we're running out of time, I'll just paste it in. So we'll write a function to actually call the LLM with this prompt. Say analyze neighborhood data. We'll pass in our couple of stringified data frames. And then we're going to create a new message to the Anthropic API with that prompt as our content. Anthropic, basically, their API, you basically pretend like you're having a ChatGPT or a Claude conversation just via the API. So you can structure all of these messages in. we'll basically pass this in as our first message, and the data that we've configured here will automatically be inserted into that. And then we just call the model with this really simple call here, Anthropic messages create. We're using the 3.5 Sonnet model, which is their latest, smartest, greatest model, configuring the max tokens, etc. And then here we're calling it. And let me just yank this out temporarily. And let's run this and see what happens. So we've configured our model now, and let's call it, let's say, analyze neighborhood data, and we'll pass in all of those stringified data frames. And maybe we'll just like print that out afterwards. So we'll run this. It will take a second because, it has to collect all that data, pass it over to the Anthropic API. Claude has to parse it, understand it, think about it, and then stream a relatively complicated result back to us. So it takes like, 10 to 15 seconds, and you can tweak this to improve it. And so, yeah, we get back that exact JSON blob that we wanted, right? We have our summary, we have our key changes, we have our categories, our notable incidents, our comparison, and our recommended actions. And if we look at our prompt, that's exactly what we asked for. So this actually looks great to me, and I think that we can use this to create a structured result. One quick thing that I always do in these is to do a little JSON.loads step, because if you don't do this, you might get malformed JSON sometimes. Maybe it just made a mistake. Maybe it only returned half the response before it hit that 3,000 max tokens window and cut off. Like actually, if I change this to be like 500 tokens, I bet we'll see this in action. And if you don't have a catch here of doing this JSON loads, your app is going to break at a later state, and it's going to be a lot harder to debug. So yeah, here we got unable to parse JSON response because it petered out on tokens halfway through the JSON. Okay, so I'll pop that back. We'll rerun this. And now I want to make a nice, pretty report out of this structured JSON. The way that I'm going to do that is with a little function I've written here to generate a markdown report. Basically, this is just manually constructing some markdown, using f strings to build some headers, some pieces in bold from the summary, and I'm just accessing the parts of this JSON here, and we're going to pass that analysis JSON with the keys into this function, and it'll sort of rip it apart, structure it as markdown. I'll run this, and we'll get markdown out. And the neat thing about Hex is that we have these text and markdown cells that can render variables from elsewhere in the project. So here, instead of, having to, well, I guess you would do like, from ipython.display import something or other, it's a lot easier to use a built-in text cell where we can write our own markdown. So we'll say like, I think I did a little sparkle. That's very AI sparkles, AI summary. And then we'll parameterize this text cell with the contents of our markdown report. And it's that simple. And if I hit enter on this, boom, it will run this now. Although it's not printing as markdown. I wonder if there's something that I've forgotten to do here. But that should work. So let's add this to our app and see. I'll add this up here, drag this up here. Let's look at my other copy to see if there's something I'm forgetting to do, or if it's just choosing not to behave. Oh, it probably has to be a markdown cell. Sorry. Yeah, silly me. That's literally the whole point of markdown cells. So I'm going to change this to be a markdown cell, which is really easy to do on any text cell. You can convert to markdown, because of the occasional edge case like this. And now when I hit enter, it will actually appropriately render that markdown. I'm going to delete this header because we already have an H1. That looks good. And now if we go over to look at our app, we see that app that I showed you at the beginning, with our data and AI summary, and an AI summary that's completely responsive to changes in our upstream data set or user inputs. Albeit a little slow. I think if we were spending more than 10 minutes on this, we could tweak it a little bit. But given that we only did this in a couple of minutes, the performance is, I would say, moderately acceptable. There are ways you could speed it up, including like using different models, figuring out a more clever way to pass the data in a more like concise or structured format, changing how long the actual result output is here. This response is pretty long. There's a whole lot of things you could do to make this faster, but I'm pretty content with this for now. I hope that you've sort of understood like the gravity of this pattern. It's very, very specific to San Francisco public data here, but you can kind of imagine how you could apply this pattern to absolutely any data set. You take your data, you sort of prepare it for passage to the AI in some manner. You write a quick prompt that explains what you've got, presents it in a structured manner, and is very specific about the summary that you want to get out. I think this like comparison and percentage changes is one of the coolest things to configure flexibly without having to do like a ton of Python code. Um, and then you think really carefully about the response object that you want to work with and ask for that, pass it in, ask for your response, render it with Markdown. It's that simple. And I'll share this app with you all so you can sort of pick it apart and explore it yourselves. And with that, I think I'll move over to questions, and you're welcome to keep asking questions about this app. We can explore it further, tweak it, or just anything Hex related that you're interested in. I'm happy to answer. And if any of that didn't make sense, please say so, and I'll clarify. Okay. Let's look at some questions. We have a question about the data set. Just curious for the SF real estate demo. Are most of the original data sources public APIs or some bulk file imports from local government sites? Great question, Norman. They were both. I created all of these for a hackathon that we ran a few months ago. And if we look at our data browser, in the demo data, SF public data schema here, and you actually have this in every Hex instance. You have access to this demo connection and all of this San Francisco public data to play with yourself, which is cool. I basically scraped a bunch of different APIs as well as the official San Francisco government pages, and downloaded all their data sets and loaded like a crazy amount of data about everything you could possibly imagine about the city into Hex. Okay, question about where my API key is saved. Yeah, that's a good one. I mentioned really quickly that like little secrets mechanism. If you actually Google like, or if you look up like learn.hex.tech and then look up secrets, you'll find the documentation on this, and I'll just paste it into the chat as well. There's a couple different ways that you can configure environment variables in Hex. I'll just go back to the project to show you. If we go to the environment tab over here, or sorry, the variables tab, you can configure environment variables, which are your standard like environment variable that you can access by saying os.environ, what do we call it? var. But if you had your API key in there, that would be a little bit insecure because then any user of this notebook could read your API key. So we have this thing called secrets, which basically are environment variables, but they're securely stored, and readers of the project, or sorry, editors and like admins of the project can access them. So like I can see my key here. But if somebody prints it out, or if it like accidentally gets printed out somewhere in a project, which totally can happen, it says secret value. And so I'm just passing in this variable here and it's reading from a secret. Just a nifty little pro tip. Okay, let's find some questions about the specific AI example. James says, what's the best way to test the AI output to ensure it is not hallucinating statistics instead from the data? James, that is the billion-dollar question, I think, at large. Nobody's figured out a great like general purpose way to do this. People build evals essentially for specific cases. So you could like, if you were going to productionalize this internally, what I would do would be to come up with 5 to 10 cases or neighborhoods in this case, or whatever you have, where the answer, you've ground truthed it, you've checked it, and basically you set those up as tests, just like you would, like testing a DBT model or a SQL pipeline or a piece of code. And you want to just like rerun it every so often, make sure that there's no changes to your prompt or to your data structure or something that's causing it to hallucinate. And over time, if you build up a big enough eval set, you can sort of wrap your hands around overall performance. It doesn't 100% eliminate hallucinations because, they hallucinate for sometimes like non-easy to predict reasons, but it's generally a good practice and helps you sort of like keep track of performance over time at least. And the less big-brained answer is like this is why the app has more than just the AI generated summary, right? This is why I'm also giving a map view where you can view individual data points and where I'm giving these chart views where people can browse the aggregated data or like, drill into a specific part of the data if they want to. I think with these AI summary stuff, it's really important to be like more than just a chat bot that dumps you out the insights and you take them for granted. I think that's why this pattern is so helpful and powerful. And I think it's so cool because, we're giving people these like spoon-fed quick insights, but they're immediately able to be ground truth or backed up, or you can copy and paste the actual result and the rationale. And I think that's kind of cool. Does that answer your question? Um, a few more questions. Any intentions on making this a potential default component available? Yes. My intentions are strong to do that. I think we haven't talked a lot about doing this internally, but components have some work to do in general that we're really excited about to basically make them both accept input and output. It sounds like you're familiar with Hex if you're mentioning components, but like right now, components pretty much just are a way to import pre-configured outputs. They're not like a transformation step that you can pass something through, and they don't take an input and an output like a function. So once components do accept inputs and return outputs, then we're definitely going to do that. And for those that are scratching their heads, components are a thing in Hex that basically lets you package up bits of code from a notebook and put them in a library that your whole organization can access and import as sort of like a package, essentially. And they're managed and versioned separately. So, you can have like a component that's shared out to your whole organization that's owned by the data team, centrally managed and versioned, and then everyone else imports it into their own project. So Cyrus is saying like a default component that, or a component type rather, that would let people do this quickly would be really cool. Um, okay, what else have we got here? Kenny asks, how can we change the font size in table displays? Oh, Kenny, straight to my heart. You cannot change the font size in table display cells yet. I know we're thinking about some broader styling things with table displays as we work on like formatting and stuff like that. But right now, you can't change the font size there. If you absolutely must change the font size, then you could probably use like a styled pandas data frame to do this. Like maybe we can ask Magic to do it in the time that we have. Render, please calls filtered, styled data frame with big font size headers. But our native table displays don't let you configure that yet. Oh, so there you go. You have some options here, but yeah, the native table displays don't allow that yet. Okay, what else? Rahul is asking, what's the differentiator between this and AWS SageMaker / Databricks? Rahul, I think the biggest and most obvious example there is that this is, more than just a notebook. I think I hope that's sort of become obvious through this demo that like the interface into it is a notebook-like interface, but this thing that we've built, like if we look at this app, it's significantly different than the kind of report or project or output that you could imagine building with a traditional notebook. And the flow, tying directly into your SQL warehouse and working across SQL, Python inputs, app building, et cetera. It's sort of this novel paradigm that's a little bit to the side of SageMaker or a traditional Databricks notebook. I'm happy to follow up more on that if you want, but I would say it's not like trying to be a better SageMaker or a better Databricks book or something. Like we're building more of a complete workspace for doing all of your data science and analytics needs rather than just like a very specific machine learning pipeline flow like your classic Jupyter Notebook or Databricks Notebook. Rahul, follow-up question. Can you show the notebook to data app? Oh yeah, I can't believe I skipped that. You saw a tiny bit of this, but basically, once you've done your analysis in your notebook, you've been working across all of these cells, running queries, building tables, creating maps and charts. All of these cells, these elements, become like little atomic elements you can use to build an app. So if we go over here to the app builder, let me just like reset this layout so we're working with a blank slate. You have a drag and drop canvas that you can use to turn all of those elements, regardless of if they're from Python or SQL or whatever, into a report or an app. So let's drag some of these things in here. Drag in our sliders and sort of reconfigure those, stretch these out. Where's that map? Here's the map. Drag the map in. And you can resize everything just how you want. We'll leave it like that. We'll drag in our AI summary. Oh, I guess that wasn't exactly what I wanted. And you can imagine how you can construct the app this way. There's a ton of different features here, like you can add multiple tabs to your apps. You can actually pop apps into like a slideshow style presentation mode. There's a ton here, but the core methodology is that, yeah, every single thing that you've done in your notebook becomes an element you can use to drag and drop your way into an interactive app that you can then publish out. And then anyone can access with just a URL. So like I'm going to share this in here. And I'll also be sharing this out in the link. Oops, I need to share that with all you guys. I'll be sharing this out in the email after, and you'll all be able to get hands-on with it. Okay, we've got 1 minute left. Yes, there is a free trial. If you go to hex.tech and click Get Started, it might not work because I'm already logged in. But yeah, you'll be able to create an account. You'll be dropped into a free 14-day trial of our like paid Teams tier plan. We also have a professional tier that's a little bit cheaper, and then we have a community tier that's free forever. The general concept of the community tier is that like it should feel pretty good for one person to work in as like a personal workspace for data. But if you're doing things with a team and collaborating and working in, like a real company fashion, you're probably going to want to start using the features that require you to pay us. But yeah, you can totally use it for free. Okay, one more question. Feel free to drop while I answer because we are at the half. But Norman's asking, do you know of a use case where Hex is part of the pipeline for a high volume streaming data source? At what stage in the data flow did it appear? Norman, I'll follow up with you on this after. I'll send you an email. I would say usually Hex is used in these cases as like last mile report delivery stage, not as part of like an intermediary transform or ETL or scheduling substitute. Generally, if something is like super real time, high volume, you're going to want to be using a proper data flow tool there to send the data through. But yeah, I mean, I don't know if you realized here because I was blitzing through things pretty quick, but like these SQL cells are just wired up. Whoa, that's a lot of data. These SQL cells are just wired up directly to our Snowflake data warehouse. And you can configure a cache, but you can run without cached results. And you can also configure your entire notebook to not ever use cached results. And so, you can basically create a real-time view as long as real-time into your data warehouse is acceptable, or, into an S3 bucket or anywhere you can read data out of, or like a Postgres data warehouse or whatever. So you can theoretically create a real-time app there, but yeah, I wouldn't use it for like scheduling and transformation. Okay. That was a lot of stuff. Thanks all for watching. Let me know if you have any questions. You can email me or reply to one of the invite emails I sent y'all, and I'll be reaching out soon with some more assets, like a recording, links to this app that we were working in, and a couple of helpful documentation links. Cool. Thanks all.